Hello! In this video, we're going to prove the theorem regarding equivalent functions. So here's how it goes. Suppose f and g are both functions from a to b. Then, for every x in a, f of x equals g of x. If and only if f and g are equal to each other. Now some of you might be like, wait a minute, how is this a theorem? It seems like this would be a definition for two functions to be equal to each other. Okay, so if this isn't a definition, what does it mean for two functions to be equal to each other? Now remember, functions are really sets of ordered pairs. So really, to say two functions are equal, we're saying two sets are equal. So really, every ordered pair in F is also in G. Every ordered pair in G is also in F, right? So we can see this isn't exactly the definition, it's rather a theorem, right? We can prove that this is true. So we're gonna prove it. Now notice this theorem contains if and only if. So you can imagine what we're gonna do is we're gonna prove that if this is true, then this is true. And we're gonna prove if this is true, then this is true. So let's start by proving the forward. Right, we're going to prove that if this is true, then this is true. So, assume for every x in a, f of x equals g of x. Now, our goal is to prove that f equals g. So, what we can do is we can prove that f is a subset of g and g is a subset of f. Right? That's how we're going to do it. So first, we'll prove that f is a subset of g. And to do that, we're going to let some arbitrary element be in F. So for instance, let a comma b be in F. Now, since F is a function from a to b, we know for a fact that a is an element of a, b is an element of b. But also, if you recall, the thing that makes functions special from relations is we can say that this second value, b, is equal to the value of f at a. In other words, we also know that b equals f of a. Okay, but notice, because a is an element of a, and we assume for all x in a, f of x equals g of x, it follows that we could just replace the x here with a, and we get that f of a equals g of a. Now, b equals f of a, so b equals g of a. But this is equivalent to saying that a comma b is an element of g. So at this point, what we have shown here is if we considered any arbitrary element of f, that same element is going to be in g. So we have shown that f is a subset of g. Okay, so we've shown that f is a subset of g. Now I want to show that g is a subset of f. So now we're going to let a comma b be some arbitrary element of g. You can imagine we're going to have the same sort of argument that we had here when we let a comma b be an arbitrary element of f. Turns out, just as a comma b is an element of g, we're going to see that a is an element of a, b is an element of b, but in this case, b equals g of a. But again, since a is in a, and for every x in a, f of x equals g of x, f of a equals g of a. And since b equals g of a, we know that b is equal to f of a. And of course, this means that a comma b is an element of f. And so, again, what we've shown here is if we consider some arbitrary element of g, we find that that same arbitrary element is also in f. Therefore, g is a subset of f. And because both f is a subset of g and g is a subset of f, we have that f equals g. And so at this point, we have proven that if this is true, then this is true. So now what we've got to prove is that if this is true, then this is true. So now we are going to assume f is equal to g. Okay, so what we want to prove here is for every x in A, f of x equals g of x. So give me any x in A, right? I like saying that. That was good. All right, so given some arbitrary element of A, we want to prove that f of x equals g of x. Now, because x is an element of A, and f is a function from A to B, we know that f has a functional value at x. And so what we could say is y1 equals f of x. So let y1 equal f of x. And similarly, because g is also a function from A to B, that means g also has a functional value at x. And therefore, we could say y2 equals g of x. And therefore, x comma y1 is an element of f, x comma y2 is an element of g. But since f equals g, because x comma y1 is an element of f, we know that x comma y1 is also an element of g. Now, notice what we have here. We see that x comma y1 is in g, and x comma y2 is also in g. But remember, g is a function. So what that means is that x has to map to a unique value. And because it must map to a unique value, what that means is y1 must equal y2. But y1 equals f of x, y2 equals g of x, therefore f of x equals g of x. And at this point, because x was arbitrary, we were able to prove f of x equals g of x. This means that for every x in A, f of x equals g of x. And so really, we have proven that if this is true, then this is true. And so we've proved both parts. So this completes the proof. So yeah, that's pretty much it for this video.